sometimes I've seen things like a north 100 degrees west, and I don't know the exact proper way. I mean, all I've known is bearings. I mean, I've heard it like all over the movies, but I've only known it from here. And so to me, this seems right. I don't know if it's the absolute right. I don't like when I see this. So everything I do for me and everything on the test, that would be wrong. That would be wrong. And so let's see what that would look like. Northwest 100 degrees. So that's passed by how many degrees? 10. So in reality, this should be south 80 degrees west. Right? Because they said north 100 degrees west, so this is still 180 degrees. And so really we're supposed to do south first, north or south, the west second, and the degrees in between those two places. That would be the 80 degrees. So if you see an answer in the back of the book, I'm going to always make it right where it's less than 90 degrees. If they tell you you're going to travel due north, I don't know if you've ever heard your parents or anybody say that. Due north, that means I'm only traveling straight north. Now you can say due south, due east, due west. It's just the most popular I hear is due north. But any of those just mean that there's no south or west. You're literally traveling only in that direction perfectly. And I noticed throughout this year, there's a couple word problems I'll assign that they might use a due north. But most of them will give you a bearing. It's not a true north, south, east, or west. All right, so now let's try a problem. It's probably best, instead of me reading it, is if you want to open up the textbook so we can just read it together. You see how this looks, and maybe you can ask me a question. I'm sorry, I guess I should tell you page 553. We're going to be doing example number 6. In fact, let's play with the drawing above in example number 5. So 553, that drawing called figure 4, let's see, figure 4.106. So I'm going to ask you some questions. Maybe we're going to go silent, and you kind of try to write something in your notes on what you think it is. So tell me what you think the bearing is for B, ray B. Write out the bearing for that. And now I'll write it. Okay? I'm going to pick the easiest ones first, just to make sure we're all on the same page, and then I'll make the more difficult ones. Try D. Try to write that bearing. So I see that you start south. I'm going to be heading easterly, and in between those two is 25 degrees. South 25 degrees east is my bearing. Now let's try a little bit more difficult one. You got to think about it a moment. Try A. North 70 degrees east. And then try C. So south 15 degrees west is my bearing. Everyone okay? Okay, so let's go ahead and read example number 6 and try to do that. A boat leaves the entrance to a harbor. The moment I read that, I am drawing my picture and knowing that right there is my harbor. I'm leaving the harbor. Probably some dock. This is where he's going to take off from. Okay, so now I'm ready. A boat leaves the entrance to a harbor and travels 25 miles. That's the length of the segment. My directed arrow, it's got a length and a direction. 25 miles on a bearing of north 42 degrees east. So I just stop and I'm going to go ahead and draw that out. So it's going to be north and east, and 42 is almost halfway. And I try to make it kind of accurate. And I'm going to put an arrow and a dot, and I'm going to put in a 42 degrees here, and I'm going to put 25 here. I should make that a little bit bigger, sorry. Now, if you still need to do this for a little while. Okay, so now I'm going to keep reading. Figure 4.107. Oh, I see. They've got it kind of sketched out over there for us. Shows that the captain then turns the boat clockwise 90 degrees. Okay, here's the then. He's out here 25 miles on that bearing of north 42 degrees east. Now he's got to make that turn of 90 degrees clockwise. So do I go right or left? Right. So I'm going to go this way. So that means I'm going to do this. I'm going to put a box here to show 90 degrees. And now what do I write? So all I did was show the turn and travels 18 miles. So I guess if I made that 25, I need to make that a little shorter just so I can try to get a little bit of a real feel for it. I'm making it a little shorter. If that was 25, I probably should have been a little bit shorter than that. Okay, so let me see. Travels 18 miles. So I'm going to put my arrow and my little dot to show that's a length and an arrow. Okay. On a bearing. All right, so now they're telling me how he's traveling. That means for me to do a new bearing, I'm going to drop in another north, south, east, and west. It's like another graph so I can get a feel for this. Because he's traveling how? Southeast. That's confirmed, right? Isn't it a southeasterly direction? 48 degrees. That means 48 belongs in here. Only in here. Right? Let me get out of the corner. Right, so I keep drawing these new north, south, east, and west so I can figure out how that arrow is traveling. Each arrow has its own, has a bearing. You know, you don't have to always just think of it from here. I can think of it from here, but if I want to see that this guy's traveling southeast, south 48 degrees east, I drop in a new one, and so now I know that this measurement is 48. Well, I know the balance of this. I mean, I don't know what I'm going to do with it yet because I didn't get to the question. I'm just drawing what I read. Okay, questions so far? Let me continue and see what I'm supposed to do now. At that time, I guess here, A, how far is the boat to the nearest tenth of a mile from the harbor entrance? Wasn't that the harbor entrance? So I guess what I'm supposed to do, maybe I'll draw it in red. I'm supposed to find the length of the red segment, correct? So wherever he's at, I'm supposed to find out how far away he is from the harbor entrance, sorry. But now I'm going to not think bearing, and I'm not going to think word problem. I'm going to go, oh, that's a right triangle, right? And that right triangle, and maybe that's too much because these things are going to get really messy. So I draw a separate one on the outside so I can see it clear and grab the information that I need. This is what I'm supposed to be looking for. They told me he traveled 25 miles here and 8 miles here. Okay, that's a no-brainer. Once I extracted the information that I needed. 18. Oh, 18. Okay, so now I'm just going to do a Pythagorean theorem. So my hypotenuse is the x squared. So 25 squared plus 18 squared, well, that doesn't look like a fun number to do. So I'm not going to do it. I'm going to let my handy dandy calculator do it for me. All right, what do I want? 25 squared. 18. Yes, how can I help you, sir? Oh. Yes. 324. So what's that? 9 and 4. Oh my Lord Almighty. So what did it say? To the nearest what? Tenth? So 30.8. You can see it. So that's part A. 30.8 what? Miles, I think. Oh, it even tells me in the book. I know it tells me in the book, but it's nice to do it just so you know how to do it. Next, let's see what the next question is. B. What is the bearing? Uh-oh. So I now know that the bearing, I need a bearing here. So maybe I'll tell myself that's what I'm looking for in the answer. I need a bearing here with the degrees in the middle. That's what my answer is going to be. What is the bearing to the nearest tenth of a degree? So my degrees has to be point something, one place, of the boat from the harbor entrance. So that's always the confusing piece. So north 77 degrees east, yes. Okay, so I'm going to make sure. So the confusing piece to me is always at the end, from where? Sometimes they're going to ask you from where he's at. Most of the time they're going to ask you as if, didn't he take a long way? I mean, sometimes you're forced to, especially like an airplane. I mean, they have all kind, you can't even see it, but it's like a freeway up there, you know, and they have to go a certain place so that planes don't hit each other. Okay, so it's not as bad on the water, but maybe because of current, storms, whatever's in the water, you're going to hit something that they have to do this too. So they're asking, usually what they're asking is from here, what would have been the proper bearing to get to here? What would have been the shortcut? Okay, so that's what they're asking. So far, we can put in both of the letters. What we just don't know is the degree. That's the part that's going to torture us. So we know we can put in a north, and we know we can put in an east. What I don't know is the degrees, and that's usually the difficult part. So do I want the degrees between the red and the north, or the red and the east? The red and the north. Because it has to be between the north and the east is that degrees. So basically, in what I need, so this piece here is this piece here, plus another 42. Right? So this whole angle that I'm supposed to put here, it's the 42 degrees plus whatever's in that angle right there, correct? Okay, so I just need to put down 42 degrees plus that theta thing. How am I going to find, I'll call it theta. How do I find that? Tangent. And what kind? I mean, it's tangent. No. The word tangent is right, but inverse. Because if I just put down tangent, you can't see that. Tangent of theta, and I want theta, is 18 over 25, right? Opposite, okay. But I need this answer, so I have to do the inverse. Tangent inverse of 18 over 25 to get my theta. So I have to think inverses. It's tangent. I have to go from, oh wait, I'm in degrees now, bearings in degrees. So now I'm not going to write pi over 2, I'm going to write from 90 degrees to negative 90 degrees. Because this is a positive ratio, this is going to be a positive angle measurement, so it's going to be in quadrant 1, correct? Okay, so I'm going to go ahead and we might as well just use the calculator. That's just the best way of getting that. There's no other way of really getting it. So I need to make sure this time that it's not in radians like we've been doing. I have to now get it in degrees. I now have it in degrees. So it's 18 divided by 25 equals, and now I got to get my inverse of tangent. So it looks like I got a theta of approximately, I think I said to the 10th place, 35.8 degrees. Yes?
Do we have to use a calculator, or are we going to be able to do without calculator?
There's no way with that one, with 18 over 25, you have to use a calculator for that. Or I could give you an old school thing where I had a piece of paper with all the trig functions on it. I'm not going to do that. I'm going to let you use calculators. So that is this little piece here. I need to add it to my 42. And so that would be what? 77.8 degrees. I didn't leave myself a lot of space in there. And that's exactly what they got to in the textbook. So this is a really a picture-oriented problem. There is no way around it. It is a picture-oriented problem. On the next page, up at the top, the red, checkpoint 7. Let's go ahead and let's do that problem also. This time they didn't even give us a picture to help make sure we understood it. So let's try that one also, and then I'm going to set you free to let you start doing your homework. And I would advise for you, I mean, I don't know where you are from last night's homework on the difficulty, but I would guess right now that the bearings might be a smidge more difficult just because they're new than last night's homework. So I might want to finish the day doing that homework. And again, you have until 9:30. So we should be done here in 5, 6, 7 minutes, and you'll have a little over 30 minutes to work on some of the bearing homework. So let's go ahead and let's try this. All right, let's see what it says. Checkpoint number 6, 554. You leave the entrance to a system of hiking trails. So I'm here. And hike 2.3 miles on a bearing of south 31 degrees west. South and west 31, so not too big. And let's see, I have to put the 31 degrees in here. And then it's how far? 2.3 miles. Okay. Then the trail turns 90 degrees clockwise. So I'm traveling like this, and so clockwise would be like that. And you hike 3.5. Oh, I should have went much further. On a bearing of north 59 degrees west. Maybe I'll use a different color. North, yeah, it is northwest, and so the 59 goes in here. I don't know if I need that. I didn't need it last time, but, oh yeah, I did. I did need it last time, actually. All right, now what? A. How far are you, distance, I can tell that's going to be on a triangle. How far are you to the nearest 1/10 of a mile from the entrance to the trail system? So they want to know that. So I see my right triangle. I'm going to do that in part A. I'm going to draw all my pictures here. So that's what I'm supposed to know. They told me that was 2.3. You told me that was 3.5. That's right triangle, so I can use Pythagorean theorem again. And I didn't cut anything off. That's actually what's saying in my calculator. And what did it say? Oops, I went the wrong way. To the nearest 1/10. So it looks like it's approximately 4.2 miles. So that's my answer for A. B. Let's see what B's got to say. What is your bearing? Well, that means they want something with a bearing. to the nearest tenth of a degree from the entrance to the trail. So, if that path, maybe they had to go around a mountaintop. If they could have cut straight through, they want to know what that bearing is. So tell me what the two letters would be. What's the first letter? South. What's the second letter? West. And what I need is the degrees, I almost said that wrong. Southwest, all in here. All in here, correct? All in here. So I can see this really didn't help me. This is not coming in helpful today. There's other word problems you might need that. All I need to know is from here to here. Well, I already know from here to here, that's a 31 degrees. I just need to know in here, which happens to be here. So it's 31 degrees plus my theta, right? And that will be what I put there for my southwest, my south whatever degrees west bearing. So now I have to come over here, and I'm going to do tangent again on this one. So tangent of theta is 2.3 over 3.5. No, I can't do that problem. It's my inverse tangent. Now I'm just going to pick up my cell phone and make sure I have it in degrees. And then 2.3 divided by 3.5, and then inverse tangent in degrees, and I get approximately 33.3. So 31 degrees plus 33.3 degrees gives me what? 64.3 degrees. So my drawing wasn't very accurate, obviously. My drawing looks like it should have been like 85 degrees. Again, it's a sketch. Yes?
All the triangles can be 90 degrees.
There's nothing about all, but this is trigonometry. So trigonometry does come from right triangles. It's not always easy. You'll see. All right. You have 35 minutes. And let's see, bearing problems begin where? Where do they begin? They begin at 51. 51, and where does bearing end? At 58. So there's not a lot. 4 problems. See how far you can get here in class.